Hello there, statistics people. I bet you woke up this morning thinking, I'd really like to learn how to use the normal distribution. Great news! I woke up this morning thinking, I'd like to teach you how. And if you give me 6 minutes, we'll be able to see how we solve normal problems using standard normal distributions. You ready? Let's go!
Give me 6 minutes and I'll teach you something new. Now, let's get to work.
Mark here from 6 Minute Statistics, and I want to show you how to take any normal distribution and make it solvable by using the standard normal distribution. I've created several videos showing you how standard normal distributions work. I've showed you how to use cumulative tables, inside tables, and you really need to be strong in those topics before moving on with this one. Once you master the standard normal distribution, this video is for you. The general idea here is we're working with normal distributions that have a mean and a standard deviation that's different from the standard normal. So how do we take other normal distributions and solve them using the standard normal? Well, we change them. We as statisticians will tell you we transform them, and that's our really nerdy way of saying we make other normal curves look like or behave like standard normals. Sounds complicated, right? It's really not. We're going to take the z-score formula that we've seen many times before, and we're going to use that to change values from the normal curve that we're interested in into standard normal values that we already know how to solve. Now, the process isn't overly difficult, but there are some details that I need to point out along the way. In order to do it, let's take a look at an example. My good friend Brandon owns Roots Tap Room and Wine Bar in my hometown of Plant City, Florida. He tells me the most common pour of a glass of wine is what's called the 6-ounce pour. That means his waitstaff attempts to pour 6 ounces into the glass that they're serving to the customer. Now, while his staff does an excellent job, and I'm talking to you, Phil and Travis, they're not perfect. We can't get exactly 6 ounces poured on every single pour. Suppose I tell you that the amount of wine poured into the glass follows a normal distribution. It has a mean of 6.05 ounces and a standard deviation of 0.02 ounces. Now, I want to use this normal curve to answering the following 3 questions. First, what's the probability that a pour is less than 6 ounces? In other words, what proportion of the wines have less than the advertised 6 ounces? Second, what proportion of them have a pour that exceeds 6 ounces? And finally, what proportion of the pours are between 6.03 ounces and 6.09 ounces? Now, we're going to try to use the normal probability distribution to solve this question. So the first question I asked, what's the probability the pour is under 6 ounces? Imagine, if you will, a normal curve with a mean of 6.05 ounces. That's what we're working with in this problem. And now I'm interested in a value of 6 ounces, which obviously falls below or to the left of the mean. And I want to know the probability or the proportion below it. We don't have a normal table to solve this. We don't have a normal table for 6.05 ounces with a standard deviation of 0.02. So what do we do instead? We transform it. We make it look like or behave like the standard normal and then solve that probability using one of the tables we already know how to use. So I need z-scores. I need a z-score for the value of the mean, and what you'll notice is every time we look at a value of a mean in a normal curve, when we create a z-score, it's going to end up being the value 0. And so what we really need to concentrate on is what's the z-value for the other point or points of interest. There's only one in this case. What's the z-score for a pour of 6 ounces? So we're going to take the value of 6, subtract the mean, divide by the standard deviation, and in this case, we're going to find that the z-score is a negative 2.5. So the probability of the pour is less than 6 ounces is the same thing as the probability of getting a z-value that's less than negative 2.5. What that's telling me is 6 ounces falls 2.5 standard deviations below the mean. All normal distributions have the same probability when you go 2.5 standard deviations below the mean. So we look up the negative 2.5 in one of our normal tables, and we find the probability below a negative 2.5, or the probability less than a 6-ounce pour, is 0.0062. That means 0.62% of the pours are less than the advertised 6 ounces. Way to go, Phil and Travis. All right, so if I have 0.0062 below 6 ounces, what's the probability above? Simple, right? It's a normal distribution. Total area under the curve is 1, so the probability above has to be 0.9938. And that's how we work with normal problems. You change them to standard normals, find the probability in the standard normal table, and you get your answer. How about that question I asked where we were looking for the probability of pours between 6.03 ounces and 6.09 ounces? Well, let's start with that curve, and now we notice there's two different values, the 6.03 and the 6.09, that we have to calculate z-scores for. Once we do the math, we find that the z-score for the 6.03 is the z-value of negative 1.00. That value falls one standard deviation below the mean. The 6.09, that's a positive 2. That falls 2 standard deviations above the mean. So I can ask for the probability between 6.03 and 6.09, or I can ask for the probability between a z-score of negative 1 and positive 2. And so I head back to my table. Using our MAD table skills, whether it's the cumulative table or the inside probability table, you need to be able to find that the probability between the two values of interest in this case is 0.8185. 81.85% of the pours result in a pour amount between 6.03 ounces and 6.09 ounces. And that's how it's done, my friends. This is a really good example of what the typical normal probability problem looks like. Your job is to be able to answer any probability that I throw at you. And when you're done, if you're the appropriate age, I suggest you go out and get a 6-ounce pour of your own to celebrate your success. And if you happen to be in the Plant City area, I recommend you stop by Root's Tap Room and Wine Bar and tell them Mark sent you. Cheers. It's time for you to get to work.